Now, while we are focused on making renewable sources more reliable, we should also try to optimize already existing sources to get the best out of the situation. This is methane. It is an organic compound which is a really good fuel. But it also is a greenhouse gas, so an excess of it will be counterproductive to our goal. Methane or natural gas today is transported using a pipe network, and the problem is that these pipes could randomly produce a leak. These leaks, if not detected, could cause major property damage and just overall global warming. Nowadays, we have these sensors which try to detect gas leaks. They are also wireless sensors because that much wiring won't be feasible at all. These sensors aren't just one type. They are a combination of smaller sensors like acoustic sensor, pressure sensor, or gas flow sensor. For such a technology to be widely used, we face three major problems. First, there would be a lot of environmental disturbances which could produce wrong alarms. Our second problem is that we need to organize and process that much data to produce some sort of conclusion. Our third problem is that some sensors could be faulty and damaged. So we need to find a way to correlate each data to other sensors to be more accurate. Even in these problems, there are already some solutions, like we have the wavelength technology to diminish external disturbances. We can also use evidence combination and correlation between sensor data to account for faulty sensor output. The machine learning part in this is the classification part, in which we are going to use support vector machines. So we are only going to discuss that. Support vector machine is a conventional machine learning classification algorithm, so you aren't going to see any neural networks here. The basic idea is that SVM uses inputs and classifies them into different states. In our case, the input would be the sensor data and the output would be the state of the pipe, either leaked or normal. This is also a binary classification because we only have two outcomes. You might be wondering, why can't we just check if the pressure is below some value to alarm for the leak? But that might be a part of the natural variation in the gas transport, not a leak. So we can't look at individual variables. We need to look at the overall behavior of the gas, and SVM does that. For example, we could use gas density and pressure. These are different variables, but how they are related and how they change will help us find the behavior of the gas. So we plot the points from already present data. Here, the maroon points means the pressure and density values corresponding to a normal state, and the yellow points mean the pressure and density values corresponding to a leaked state. The main function of SVM is to divide the graph into proper regions like these, so whenever a new point is introduced, depending on its location in the graph, it can be classified as either leaked or normal. This is the final diagram for our model, and as you saw, the machine learning is actually really simple in this. This just shows that you don't need to implement neural networks or complex deep learning for your problems. Sometimes the solution doesn't even sound like learning, but machine learning is a really broad field. So anytime you have data and you want to find some relations in it, then it's probably machine learning that you're looking for.